Welcome back, my dear friends. A very good morning, good afternoon, good evening to all of you wherever you are in this part of the world, whether in India or abroad. And as you know, this is the DADM, which is, as you can see on the slide, which is Data Analysis and Decision Making 2 course under the NPTEL MOOC series. And this DADM 2, as DADM 1 was, is basically for 12 weeks, which is 30 hours, 30 hours being basically split into 60 lectures, each for half an hour, and each week we have 5 lectures, and after each week we have assignments. And as you can see from the slide, we are in the 8th week, which is the 37th lecture, which is the second lecture for the 8th week. And my good name is Raghunandan Sengupta from the IME department, IIT Kanpur in India. Now, if you remember, we were discussing about the multi-criteria decision making VIKOR, and we have already discussed for whole set of 1 week about Electra, one set of 1 week for TOPSIS, and then initially we have discussed about AHP also. Now, in VIKOR, the similarity and dissimilarity about TOPSIS and VIKOR had been discussed. One was basically linear normalization, one was vector normalization. We also discussed the concept that in VIKOR we will consider the distance measures, considering the concept that what distance measure do you use. We will use the LP norm, and I will show you, if you remember, I did mention in the last lecture, which was in 36th lecture, that how the distance measure could be understood. And in the VIKOR method, again I will go in the similar way, state the algorithm, take a very simple example and then solve it accordingly, and I will mention the steps as we proceed. There would not be much of a dissimilarity apart from that how you calculate the so called best solution, worst solution, which in many of the cases you mention as concordance, discordance set, or the distance to the PIS or distance to the NIS. So, there are different ways how you analyze the things. So, we will assume this slide is basically the essence, the one, and I did mention about that about how you will can consider the distance measure. So, as usual, consider the nomenclature. You have m number of total alternatives or goals to achieve, and for each goal you consider different criteria or attributes, characteristics, and there are n in number. So, the suffix I changes from 1 to m as in Mangalore or mango, and j changes from 1 to n as in nose or Nagpur. Now, remember one thing, that in many of the methods, or almost I should say in all of the methods of MCDM, whether AHP, TOPSIS, Electra, and specifically in VIKOR, I did mention that we will consider the attributes of the characteristics as the main what I should say quality based on which you will try to analyze each and every alternative against each other, corresponding to the fact that the criteria are there. And in VIKOR method it is simple to analyze that even if the units for the attributes are different, we will be able to form or bring some semblance of comparison between the criteria even as the units are different. So, we will consider, which I have already said, we will consider m number of alternatives and n number of criterias, and we will consider the distance function of the mapping or the functional form as CJAI, where C implies the criteria, A implies the alternative. So, such that Cj and AI would mean the overall characteristics of the criteria or the priority value which accrues between the relationship coming out from the jth criteria for the ith alternative. So, we will consider the distance function based on this. The criteria was basically we will have a weight, which I have already discussed If I am repeating, please bear with me. We will consider the weights Wj, j is equal to 1 to n, and we will have the corresponding values. So, what you are going to take, if you look at the numerator and the denominator, in the denominator you have basically difference between the max and the min as it is stated. So, Cj A plus, and this should be what should change it. So, there is no confusion, A plus minus, yes. So, we have this right. So, this is fine. So, Cj A plus is basically you take either the row or the column. Now, remember we will be taking the matrix M cross N, where M and N have their own notions which has been already been mentioned time and again from my side. Now, you will take the maximum corresponding to CGAIs and you will take the minimum corresponding to CGAIs for all the values of i's. I's means the first alternative, second alternative, third alternative, so on and so on. That means you are going row wise. Now, the denominator is basically the difference. That means you are normalizing or taking the ratios of the max and the min, and based on that you are trying to find out where do they stand. So, you have a real line, the max and mins has been normalized as the distance, which is Cj A plus minus Cj A minus, and based on that you will basically put the values where does CGAI stand, and you will basically find out for each and every j is equal to 1 till n. So, say for example, for j is equal to 1, you will find out CGAI and then basically subtract that value from the maximum value. So, which is, so we will draw the real line first. Now, what I will take is, I will take the max min, let me use the blue color. So, this is the max, this is the min. So, you will basically have the line as given, this is min, this is max. So, this distance what we have is basically the one which is, let me use the highlighter, this is the one. That means I am normalizing and finding on a normalized scale, maximum minimum. Now, forget about Wj. So, if I consider this, so for each CGAI, that particular row we have a maximum, we will try to find out the difference between them and then multiply by the corresponding weights. So, consider the weights are all equal. So, if the weights are all equal, we will basically multiply the distance which is occurring between the max and each and any individual value, normalized by the difference between the max and the min, and sum them up. But remembering that what type of norm which you are using, I will come to the norm within few minutes and explain that what the concept of norm would mean in more details. Now, if it is L1 norm, you will take the mod, if it is the L infinity norm, you will take the max, and corresponding to L2, you will basically have the Cartesian distance and so on and so forth. So, once you have that, you rank them and utilize this ranking system to further find out the scoring for the max and the min, and then find out the overall ranking of the AI1, AI2, so on and so forth, for I1 and I2 being element of the total set of alternatives. Remember, L1 and L infinity are, I am not talking about the ith one. So, that will basically be for I is equal to 1, 2, 3, 4 till m for each and every alternatives which you have. So, L1 and L infinity are used to formulate the ranking measures, where p can be 1, 2, 3, 4 till infinity, is basically an integer and denotes the distance measure used. So, what distance measures we will try to find out, we will use that. P is equal to 1 denotes, as we have already discussed that in the Topsis method, it denotes the Manhattan norm, while P is equal to infinity denotes the infinity norm, which is the max one. Now, we have done it, still I will repeat it for your own convenience. So, we will basically have different norms. L1 norm would be the Manhattan distance norm between vectors and points, where the vectors are x, vector is x1 to xn. This n has nothing to do with the n number of criteria I have. I am just taking it arbitrarily, it could be anything. So, this is just a nomenclature concept I am using. This I use that in the case of when we are discussing about the Topsis also. So, I did not mention them there, but I am again mentioning it here in order to make it clear. So, this n which is here, I am not highlighting, I am just putting my pointer here. This n has nothing to do with the concept of the criteria. Similarly, y vector, y bold will be y1 to yn, and if I want to find out the L1 norm, it will basically be the mod of the difference and sum them up from I is equal to 1 to n. Again, this n is the number of elements which you have in x vector and y vector. The name relates to distance, which I have already discussed, as a taxi has to drive in the rectangular street grid in the city of New York in the area of Manhattan. While infinity norm would give me again for x vector x1 to xn, y vector y1 to yn, it will give me the maximum values for each, and these are which I have max of xi minus yi, and LP norm would basically be between two vectors, again x vector x1 to xn, y vector y1 to yn, be the difference between the mods to the power pth 1, and then basically sum them up and find out the 1 to the power p power of that. That means, you are trying to scale them up and then bring down the scale depending on the pth power which you have. Now, let us consider an example. I am considering in a very simple case as a 3-dimension one, and you will understand why this distance measures would change as you change the norm. Consider the vector is 2, minus 5, 20, and y vector is minus 12, 15 and 0. So, that means, the x point is we go travel plus 2 along the x axis, x I am using as a vector. So, and then I travel minus 5 in the y axis, I am talking about, and then I travel 20 plus in the z axis. So, that is the coordinate system point I have. Similarly, for the point y vector, I travel minus 12 along the x axis, then I travel plus 15 along the y axis, and in the z axis I do not travel because it is 0. So, if I want to find out the L1 norm, again as per the formula, I add up all the values, I is equal to 1 to n. So, let me, I think it will be easy for you to understand. So, rather than writing n, I should write it down. So, it is easy for all of us to understand. So, let us go a little bit slow. So, 3 value would come here. Let me change this also. Let me change this also. So, for I is equal to 1, 2, 3, you find out the difference, which is, I will put the color scheme here. So, it is much easier for me to. So, this is the first one is 2 and minus 2, 12. So, this is 2 minus or minus 12, mod of that, which is 14, which is here. Then I take minus 5 or minus 12. So, minus 5 or minus 12, this minus 5 and plus 15. So, minus 5 or minus 15, the value comes out to be 20. Similarly, I have 20 in the z direction, 0 in the z direction for x and y vector. The value is 20 minus 0, which is 20, and the total value of L1 comes out to be 54. I will just circle it. I will use this value, so in order to differentiate. So, I get a value of 54. Then when I come to L2 norm, again I have this 2 value minus 12. So, it is 2 minus or minus 12 whole square, as I did as it should be, because P is now 2. When I can come to the y axis, the colors code I am using is green. So, it is minus 5 of minus 15 whole square, which is basically 20 square. So, this is 400. This value I have not highlighted for our convenience, it is 14 square, which is 196. And finally, for movement in the z direction, which is blue color, which is 20 and 0. So, it is 20 minus 0 whole square, which comes out to 400. So, square them up, add them up, find out the square root, it comes out to 996 square root, and the actual value comes out to be 31.55. There is let us consider 31.6. So, when I mention, I will be basically talking about 31.6 until unless required. So, I will highlight it 31.5. Note down one thing, 54 has now decreased to 31.5. Now, let me come to L infinity norm. Again I use the same color scheme. For x direction movement 2 and minus 12, 2 of minus or minus 12, that is 14. Then the second value is green in color, which is minus 5 of minus and minus 15, which is 20. And the last value I am using the color blue, which is 20 and 0, 20 of minus 0, which comes out to be 20, and the actual value comes out to be 20. So, the values are given as 54, 31.5. Obviously, they would be L3, L4, L5, so on and so forth till the last one, which is 20. Now, in this graph, I have mentioned very simply that how does the LP norm value change as I change the values of P. So, along the x axis, I have the values of P 1, 2, 3, 4 till 100. I have taken till 100, and along the y axis I have taken the values of LP. So, for 1 it is 54, if you remember, for 2 it is basically 30.55 whatever, for 3 so on and so forth till it goes to L infinity, which was, if you remember, the value which you have found for L infinity, which was 20. It is almost coming out to be 20, slowly it will become 20. So, if you consider the values, it goes like this, slowly asymptotically it becomes 20. So, if you increase the dimension, so here we had 3 dimension in the x axis, y axis and z axis. Say for example, we consider x1 axis, x2 axis, x3 axis, x4 axis, so on and so forth, and then we find out these values, which was n dimension. So, here n is 3, that is why it is 3 dimension. If you have n dimension, you can find out that the L1, L2, L3 and similar L infinity norm would have these characteristics, where you can find an asymptotic curve based on the value of P changing, which will have an effect on the LP norm value changing. This I just thought I will mention it to you for your understanding. So, as you change it, you will have different ranking system, and ranking system in the L infinity norm would almost be equal to each other, because closer the values of P it is towards 1, higher the distances values, if you notice it here. So, this I thought I should explain it to you, such that you understand when you do the problem. Now, I will illustrate another graph which will make things much easier. So, consider the grid system as shown in this slide, and the grid system is in a Cartesian coordinate 2 dimension. So, here we have 2 points The first one I will mark it as, let me mark it as some color, because already we have this color would be different. So, I have x vector point, similarly y vector point, whatever they are, and it is 2 dimension. So, it will be x 1 y x 2 for x vector, and similarly you have basically y 1 and y 2. We are not considering z 1 and so on and so forth in third dimension. Now, look at these curves. So, this green one would basically make you simply understand that we are taking the L2 norm, and similarly blue, red and yellow would give you a concept that we are basically use the L1 norm, different ways you take it, L1 norm. So, I will pause here, have a look, so that it makes life easy for us to understand. So, you have x vector, which is a point and a Cartesian coordinate, y vector also another point in the Cartesian coordinate, green line is the L2 norm between x and y, red one, blue one and yellow one are the different ways you can reach from x to y, and these are the L1 norm. So, now it states the green line, which is the L2 norm, is the unique shortest distance, while the red, blue and yellow L1 norm are all same and the length of 12. So, if you remember what we have seen in the L2 norm, it was 54 in for that calculation which we did. So, it will be same in whichever direction in the 3 dimensional case you are going. So, in this case it is a Cartesian coordinate, you are moving from x to y in different ways, and in that other example where it was 54, it was basically would have been a cuboid with some x and y values whatever it was stated, and you can basically take different ways of reaching from x to y. One can generalize this in the n dimension case which I mentioned. So, this is why the L2 norm has a unique solution, while the L1 norm would not have the unique solution. This would have an implication that when you are trying to utilize the L1 norm for the VIKOR method, you may get different results, but further on for L2, L3, L4, LP till infinity, your answer would be unique 0.1, and obviously the difference between the answers would start decreasing as you go for the L infinity norm. This we will try to explain through the example. So, let us go through the VIKOR algorithm and the steps and solve it using the Excel sheet for a problem. We will solve it here as we did in the last example. Assume decision on alternatives as ai, I is equal to 1 to m, and we also assume the attributes on the decision criteria goals are given by C j, j is equal to 1 to n. So, these a's are being affected by the weights of the criteria and the effects of the criteria which they accrue to the alternatives. So, this is basically when you find out the C j along with a I, you had the functional form as C j a I. Based on that we proceeded. We state the pseudocode for the working principle of the VIKOR method, and how it works we will state it very simply as we did for the Topsis method. Now, it looks complicated, it is not. You have to just assume the steps and we will basically utilize this accordingly. So, I would not go to immediately the define step, which is step 1, I will only go to in the input and then go back to the, once I finish the overall algorithm on the flow process, I will go back to the defining state, which is the first one. So, as usual you will have two sets of matrices. One is the x1, which is of dimension m cross n, which are the priority values which you have for each and every criteria and each and every alternative. So, as it is of dimension m cross n as it states. So, x is the m cross n matrix consisting of priority scores assigned to decision alternatives a I corresponding to the fact that the criteria goals are given by C j and the weights are given by W j. I am going to come to the weights again, even though I have repeated it, but it is just a way of discussion such that the logical flow remains. Now, in this case again the value which you will have in the matrix X non-normalized one. So, say for example, I have X 3 4, it would mean that for the fourth criteria what is the weight or the priority is accrues to the third alternative. Similarly, X I j would basically be the jth criteria's priority weights or priority values accruing to the ith alternative. Now, these are for the different attributes. So, they need to be normalized. For the normalization case, we have considered that we use for each and every decision maker the case that what would basically be the utility function, but here we are considering the fact that the distance measure should be used. Now, again I will repeat few things which I have done that in the Electra process and the Topsys process. Remember one thing, that if you consider the relative distance measures to be fixed, continue using that calculations for each and every steps for the same decision maker, point 1. Point number 2, yes, it may be true that the distance measures being utilized by decision maker 1 or decision maker 2 or 3 or 4, considering there are 5 decision makers, may change, but for simplicity we will keep the distance measures for each and every decision makers to be the same. So, if it is basically L 3, that means P is equal to 3, we will continue utilizing that for each and every decision maker. As I said, we will take the values of the weights, which I did mention fleetingly. So, weights again are basically the priority which you are trying to put for each and every criteria amongst themselves. So, if you have a weight matrix of size n cross n, it means the principal diagonals are values corresponding to W1, W2 till Wn, and the of the diagonal elements are 0, which means that W1 is the overall weight which I can accrue when I compare the first criteria with respect to the rest. Similarly, W2 would be the weight which I can give to the second criteria with respect to the rest. Similarly, for the last one, which will Wn, and again we will very simply consider the weights should be add up to 1, or they are basically being normalized on a scale to 1 or 100, whichever you want to do. Now, once you have this x and w, you will basically try to find out that considering the values of x which you have, which have different type of attributes priorities, you need to normalize them. When you need to normalize them, again the question would come whether you need to basically normalize along the row or along the column. The question would again, I give the answer, is that if you follow the principle of normalizing along the row, continue using that same concept. If you try to basically normalizing along the column, continue to utilize the same concept. Now, when there are many decision makers, for simplicity we will consider that as utility functions are same, as distance measures are same, as the distance measures are being utilized by any decision maker for step by step are same, we will also consider the normalization concept also to be the same between different type of decision makers. So, once you basically have x, you normalize them along the row or along the column, and once you do that, you will basically are at the stage where you can basically start off the process of trying to find out the distance measures. Now, as required, we will consider that the actual matrix based on which we will try to proceed and compare the different type of distance would basically be the multiplication of the priority weights which are normalized multiplied by the weights, which means that we have been able to subsume or consider both the priority weights on a normalized scale plus the corresponding weights which accrue to each and every criteria. So, utilizing that F matrix. So, these are the generally nomenclature I am trying to utilize. We will utilize this F matrix in order to compare the ranking system considering the LP norm. So, P can be changed. So, as I showed you in the graph, the asymptotic one, as you change the values of P, you can have different type of rankings, but the ranking differences would basically start decreasing as P increases. With this, I will close this lecture, which is the second lecture in the 8th week, and consider more about the VIKOR method in the subsequent 3 lectures which are there for this week. Have a nice day and thank you very much.